second question. Now it's a very very good question. Second question. Please listen to this carefully. Now please see the second question. It's a very very interesting and a very good question. First let us read the question, sir. An intelligence agency forms a code of two distinct digits selected from 0, 1, 2, 3 etc. till 9 such that the first digit of the code is a non-zero, right? First digit is non-zero. The code, however, on a handwritten on a slip can however potentially create confusion when read upside down, right? If you read it upside down, it will create a confusion. For example, the code 91 may appear as 16. 91, if I reverse it, if I write it on a sheet of paper 91 and if I read it ulta, it looks like 16. That is a confusion. How many codes are there for which no confusion can arise, right? For which no confusion can arise. Now first of all, they are telling you that the digits given are 0, 1, 2, 3 till 9. The digits given are 0, 1, 2, 3 till 9. They are telling that first digit of the code is non-zero, right? First digit of the code is non-zero. And they are also telling that the intelligence agency forms a code of two distinct digits. Now first of all, how many codes can be formed? Number of codes that can be formed. First let us see how many codes can be formed. Number of codes that can be formed is nothing but equal to, now it is a two distinct digit. First digit is a non-zero. That means this position can take any digit from 1 to 9, right? It can take any digit from 1 to 9. That means there are 9 ways of filling this position. If I fill it with 9 ways, this position 0 cannot come here. This position can take any digit from 0 to 9. But the question says they are distinct digits. That means if I write for example 3 here, 3 should not be included here. So one digit will not be included here. For example 3, right? For example, if I consider 3, that means 0 to 9, 10 digits. Out of that, 1 is eliminated. Again 9 digits. Totally you can form 81 digits. 81 codes can be formed which are distinct and using the digits 0 to 9 with the first digit not a 0, right? That is what I can find out from this. Now continue the question. The code handwritten on a slip can however potentially create confusions when read upside down. For example, the code 91 may appear as 16, right? Now first of all, what are the codes which will create confusions? The numbers which will create confusions are confusing numbers. What are the confusing numbers? Confusing numbers are 1. If I write 1 ulta, it will again read it as 1. 6 will look like 9 if I reverse it. 9 will look like 6 if I reverse it. 8. Now these are the 4 confusing numbers, right? These are the 4 confusing numbers. Now how many codes can be formed from these confusing numbers? Number of codes formed from confusing numbers. From these confusing numbers, how many codes I can form? Confusing numbers. Number of codes formed from confusing numbers are, how many I can form is. Now if you observe carefully, this and this is a two distinct digits. Now this position, it can take any digit from any of these 4 digits. There are 4 ways of filling this position, and if I fill suppose 9, it should be distinct. This cannot again, it can again not be 9, so it can be any of the remaining 3 digits. That means totally I can form 12 codes using these confusing digits, right? Using these confusing digits. But think logically, out of the 12 codes which you can form, one of the code is 69 and the other code is 96, right? One of the code is 69 and the other code is 96. 69, if I reverse it in a paper, it will again look as 69 only. That means it is not a confusing number. Similarly, 96 if I reverse in a slip or a paper, it will again read it as 96 in the reverse direction. That means you should completely reverse it and then read it. That means if the sheet is like this, you should make it like this and read it. It still looks the same number 96. That means out of 12 confusing numbers, there are 2 numbers which are not confusing, right? There are 2 numbers which are not confusing when you read it upside down also. That means out of 12, if 2 are not confusing, remaining 10 are confusing, right? Remaining 10 are confusing numbers. Remaining 10 are confusing numbers. But the question says how many of them are not confusing numbers totally. Now question says how many of them are not confusing. Out of total 81 numbers which you can form, 10 are confusing. Remaining how many are not confusing? 81 minus 10. Answer should be 71. Getting the idea? I hope this is very important. 69 if I reverse. I wrote on this sheet of paper as 69. I reversed this paper completely. Still it looks as 69 only. Right? If you want, check it out. Now let us solve CAT 2001 question. Idea clear with CAT 2000 questions, right? 1998, 1999, 2000. That's what we have solved till now. No. Please write on the heading CAT 2001. We will solve some questions in CAT 2001 number system questions. Now please read this question, sir. First question. In a 4-digit number, the sum of the first 2 digits is equal to that of the last 2 digits. The sum of first and last digits is equal to the third digit. Finally, the sum of the second and fourth digits is twice the sum of the other 2 digits. What is the third digit of the number? Right? What is the third digit of that number? Now they are giving you the options as 5, 8. See, third option is 1, fourth option is 4. Now they are asking what is the third digit. Now if I take the 4-digit number as A, B, C, D, right? If I take the 4-digit number as A, B, C, D, they are telling the sum of the first 2 digits is equal to that of the last 2 digits. So they are telling A plus B is equal to C plus D. This is one equation. Next statement, the sum of first and last digits is equal to the third digit. First and last, A plus D is equal to third digit C. That is the second equation. Finally, the sum of second and fourth digits is twice the sum of the other 2 digits. Second and fourth, B plus D is twice the sum of other 2 digits, A plus C. Now if you observe this way of solving is nothing but forming 3 equations, solving 3 equations, getting the value of C. I am not interested with this method. This method will be given in some of the textbooks also or in Google. You can refer to that way of solving in Google. Now see here, I am not interested in this forming equations, all those things. Let us solve in a different way. Now what is the question? Your main question is what is the third digit of the number? If the question is what is the third digit, answer option also will represent the third digit. Now let us go answer option by option. Now if I choose my first option as 5, right? If I choose my first option as 5, I am assuming the third digit as 5. It may or may not be correct. Let us check whether all the statements will satisfy. If it satisfies, my option is correct or my assumption is correct. Now read the first statement. The sum of first 2 digits is equal to that of the last 2 digits. I don't even know first 2, I don't even know last 2. I know the last but one, but I don't know the last one. So I cannot validate the first statement as of now. Continue the statement. The sum of first and last digits is equal to the third digit. Now if I add first and last digit, I should get the third digit 5. Now to get the sum as 5, there are multiple ways. 1 plus 4 is 5, 2 plus 3 is 5, 3 plus 2 is 5, 4 plus 1 is 5. There are multiple ways. I will take one case out of this. I will take 1 and 4, right? I don't know whether it is right or wrong. I am just checking it out, right, by using numbers. Now see here, they are telling second statement sum of first and last is nothing but third. Yes, it is satisfying. Finally, the sum of second and fourth digits is twice the sum of the other 2 digits. Now, second and fourth, I don't know what is second, but is twice the sum of the other 2. What is that? That means sum of these 2 should be equal to twice that of other 2. What is 1 plus 5? 6. 2 into 6 is 12. That means if I add these 2, I should get the sum as 12, it seems. That means this should be 8. 8 plus 4 is only 12. That means the 4-digit number is nothing but 1854 according to my assumption of third digit being 5. Right? Now, please validate the third statement. Validate the first statement, because second and third statement will definitely be true, because from second and third statements only we validated or we got this number, so definitely it will be true. Check out whether first is correct or not. The sum of first 2 digits is equal to that of last 2 digits. First 2 digit sum is 9. Last 2 digit sum is also 9. First statement is true. Second statement is also true. Third statement is also true. Therefore, my assumption of 5 is also true. That means the answer is option B. over. Instead of forming three equations and making it as algebra, make use of numbers is what I am telling. Idea clear? Solve number system by numbers. That is the best way to solve number system questions. Now, not all questions can be solved by using numbers. There are some questions which cannot be solved by using numbers. I will come back to that question very soon. First write down the question. Clear, right? A power n plus or minus b power n. Next. Now please see the next question. We already solved a very good question on permutation combinations. Now let us solve one more question where usually students will make a mistake in this question. Now please here, we will also discuss what is the mistake students might do it. Now the question is like this. How many numbers greater than 0 and less than 1 million can be formed using the digits 0, 7 and 8, right? Now they are telling that the question is like this, I am giving you only these three digits 0, 7 and 8, right? I am only giving you these three digits 0, 7 and 8. Nothing is mentioned in the question that repetition is not allowed, right? That means you can repeat the digits. You are using only these three digits 0, 7 and 8. Using these three digits with repetition, you need to form numbers which are greater than 0 and less than 1 million. Now it should be greater than 0 and less than 1 million. That means it should be between 0 and 1 million. Now what is 1 million? 1 million is nothing but 10 lakhs, right? It should be between 0 and 10 lakhs, right? It should be between 0 and 10 lakhs. Now suppose for example, if I say that it is between 10 and 20, what are the numbers which are between 10 and 20? Between 10 and 20 means 11, 12, 13, 14 till 19. That means in between 10 and 20 I am discussing about the numbers. That means 10 and 20 are not included. Here also 0 and 10 lakhs is not included. Anyway they are telling that it should be greater than 0. So it is not included. Less than 10 lakhs, it is not included, right? That means the maximum number that you can form is 9,99,999, which is a 6-digit number. That means the maximum number that you can form is a 6-digit number, right? Now listen to this carefully. I need to use only these three digits. Now this position can take any of these three numbers 0, 7 and 8. Similarly, this position also can take any of these three digits 0, 7 and 8. There are three ways of filling this position and three ways of filling this position. This also can take any digit from 0, 7 and 8. Three ways of filling this. This also can take any digit from 0, 7 and 8. Three ways of filling this position. This position also can take any digit from 0, 7 and 8. Three ways of filling this position. Can this position take 0? Yes, it can take 0 because the question is not talking about a 5-digit number. They are talking about between 0 and 1 million, or it says that greater than 0 and less than 1 million. So this also can take any digit from 0, 7 and 8. Three ways of filling. 3 multiplied 6 times is 3 power 6. Students in a hurry will mark it as 3 power 6, which is incorrect. Why it is incorrect means, now if you observe carefully, now if I make this position as 0, then I will get all the possible 5-digit number. If I make these two positions as 0, I will get all possible 4-digit numbers. That is also in the given range only. If I make all three zeros, all the first three as 0, I will get all the possible 3-digit numbers. That is also in the given range. If I make all these 4 digits as 0, I will get all possible 2-digit numbers. That is also in the given range. If I take all these 5 digits as 0, I will get only single-digit number. That is also in between 0 and 10 lakhs. But if I take all the 6 digits as 0, then it becomes 0, 0, 0, 0, 0, 0, and that number is nothing but 0. But the question says it should be greater than 0. That means out of this 3 power 6 cases, you need to eliminate that one case. This one case is nothing but all positions are 0. You cannot take all positions 0 and you need to eliminate that position or that value. Out of 3 power 6, if I eliminate one case, your answer is not 729 but it is 728. So answer for this question is 728. Getting the idea? The mistake what the cat person did it when he created this question. Please see the answer options. The answer option says 486. Second option is 1084. Third option is 728. Fourth option is none of these. He should have given an option called as 729 because most of the people will make a mistake as 729, right? He should have given an option called as 729. then there would have been a confusion arising with the students whether it is 729 or 728. But anyway, he has given one more option, which is a very toughest thing to do, that is none of these. None of this is actually trickier than any other option, right? So because he has given none of this, some people tend to make mistake and they will think that 729 is correct answer and they will mark the option as none of this because 729 is not present. But 729 cases, you should eliminate that one case where all the positions are 0. I think the approach is very clear. Answer is 728. It is not 729. Please write down this question. Clear? Application, format theorem and negative reminder. Fourth question. One more question on reminder. Not basically reminder, but divisibility concept. Now see here, next one. Now your question is 7 power 6n minus 6 power 6n is always divisible by which of the following, right? 7 power 6n minus 6 power 6n is always divisible by which among these four options? 13, 127, 559, and the last option is all of these, right? And the last option is all of these. Now 7 power 6n minus 6 power 6n is always divisible by which of the following? And they are telling that n is an integer greater than 0. That means n is a positive integer, right? So n belongs to positive integers. That is what they are telling. Now see here, very easy way of solving. We know that a power n minus b power n is always divisible by, right? It is always divisible by a plus b, right? It is always divisible by a plus b if n is an even number, right? A power n minus b power n is divisible by a plus b if n is an even number. Just for example, put n value as even number 2. A square minus b square, it is divisible by a plus b. A square minus b square is a plus b into something, so it should be divisible by a plus b. That means n should be even. That means the power should be even. 6n is also an even number, right? 6n is also an even number. That means this 7 power 6n minus 6 power 6n, it is divisible by 7 plus 6. 7 plus 6 is how much? 13. That means it is divisible by 13. Now, most of the students will make it incorrect in this question because they got the answer option already and they will think that 13 should be the correct answer. 13 is the correct answer, but it is not only 13. That is where your skill set lies. No, don't stop the problem at this point. Please continue it. Now, if I again further simplify, a power n minus b power n is also divisible by a minus b. It is also divisible by a minus b. It is divisible by a minus b every time, right? If I put n value 1 or n value 2 or n value 3, that means odd or even, it is always divisible by a minus b, right? Similarly, a power n minus b power n, it is always divisible by a plus b if n is even, as we have written above, right? As we have written above, it is divisible by a plus b if n is even. Now, can I write 7 power 6n minus 6 power 6n as 7 cube power 2n minus 6 cube power 2n? This I can write it like this, right? This I can write it like this. Now if you see here, a power n minus b power n is divisible by a minus b. A power n is nothing but in this question 2n, minus b power n, this should be divisible by, right? This should be divisible by a minus b. That means 7 cube minus 6 cube. 7 cube minus 6 cube is 7 cube is 343. 6 cube is 216. 343 minus 216 is nothing but 127. That means it is divisible by 127. Similarly, a power n minus b power n is also divisible by a plus b if power is an even number. 2n is nothing but an even number. That means this is also divisible by a plus b. 7 cube plus 6 cube. 7 cube plus 6 cube is nothing but 343 plus 216. It is 559. That means it is divisible by 13. It is divisible by 127. It is also divisible by 559. That means your answer option should be all. So answer is option D. Getting the idea? It is not only 13, sir. It is also divisible by other two numbers also. Answer should be all. Idea clear? It's a classical problem where you can make use of the corollary of a power n plus or minus b power n. Idea clear? These are the three notations what we have used in this problem. Please write down this. In fact, we have solved this question in our regular class also, if I remember right. Right? Please write. Clear, right, sir? It's a very easy question. Do not make it complicated. Now, let us solve two questions in reminders, which was asked in CAT 2002. Now, please see this question. The question is, when 2 power 256 is divided by 17, what is the remainder? Now, they are asking, remainder when 2 power 256 is divided by 17. What is the remainder? They are asking. Now, there are multiple ways of solving this question. If I apply negative remainder concept, this I can write 2 power something when divided by 17, I should get the remainder as plus or minus 1. 2 power 4 when divided by 17, this is nothing but minus 1. 16 by 17 is minus 1. But I don't want 2 power 4. I want 2 power 256. 4 power 2 power 4 power 64 is 2 power 266. Now 16 divided by 7, it is minus 1. Minus 1 power 64. Minus 1 power even number is always positive. So it is plus 1. Answer should be plus 1. Now this is one way of solving. Other way of solving is, we know Fermat's theorem. What is Fermat's theorem? Fermat's theorem says that remainder of a power p minus 1, remainder of a power p minus 1 divided by p, it is always equal to 1 when p is a prime number, right? When p is a prime number. Same application I will use. Remainder of, now from this, p is a prime number, it is 60, it is 17. 17 is a prime number. That means if denominator is a prime number, the power of the numerator should be 1 less than that, according to Fermat's theorem. That means from Fermat's theorem I can say it as, from Fermat's theorem I can write remainder of, if the denominator is 17, 16 should be the power of the numerator. This remainder is 1 according to Fermat's theorem. But I don't want 2 power 16, I want 2 power 256. Write power of 16 on both sides. 2 power 16 is 2 power 256. Here also write the power of 16. 1 power 16 is 1. Same answer you will get both. Idea clear? Either use negative remainder concept or use Fermat's theorem. To solve more and more questions on negative remainder and Fermat's theorem, you should watch our regular classroom videos. These are very basic questions. In fact, it's a very level 1 question in negative remainder, level 1 question in Fermat's theorem. There are very high level questions also which are solved in our regular classes. Right? Please write down. Now, let us solve some CAT 2002 questions. Please write on the heading CAT 2002 previous year number system questions. Now listen to this question, sir. First question. Your first question is, number S is obtained by squaring the sum of the digits of a 2-digit number t. Right? They are telling that there is a 2-digit number called as t. If I add the terms of the 2-digit number and if I square it, I will get a number called as S. Right? Next, if the difference between S and D is 27, then the 2-digit number d is how much, right? The 2-digit number d is how much. Now they are asking, what is the d value? Options given are 24, 54, 34 and 45. These are the options given. Now instead of again making use of algebra, I will make use of number system. Now they are asking what is the d value. That means any one of these should be d value, right? Any one of these should be d value. I will assume that d is first value 24. If I assume it as 24, if d is 24, question says S is obtained by adding the sum of the digits of a 2-digit number and then squaring it. That means if I add, I will get 4 plus 2, 6. If I square it, I will get 36. Now d is 24, S is 36. But the second statement says the difference between S and D is 27. The difference between S and D is not 27 according to my assumption. So it is not the right answer. Ruled out. If I take the second option, D is equal to 54. S is nothing but add the terms in the digits and then square it. 5 plus 4, 9. If I square that 9 square is 87. Question says the difference between S and D should be 27. But my assumption also says 81 minus 54, the difference is again 27. Because the second statement is validated according to my assumption is also validated. That means the answer should be 54. It's a very easy way of solving if you are solving by the concept of numbers. Right? Please write down this question. I hope this is clear, right, sir? Very good question. Please analyze it and then understand it properly. Next. Please see the next question. Your next question says, let n is equal to 55 cube plus 17 cube minus 72 cube, right? Minus 72 cube. N is divisible by which of the following, right? N is divisible by which of the following? Your options are both 7 and 13. Second option is both 3 and 13, right? Both 3 and 13. Third option is both 17 and 7. Both 17 and 7. Last option is both 3 and 17, right? Both 3 and 17. Now see here. If you observe, it is a cube plus b cube format, right? Now if I apply a plus b whole cube is a plus b whole cube is a cube plus b cube plus 3ab into a plus b, right? Plus 3ab into a plus b. A cube plus b cube is what is given here. That means this term I will keep it in one side. A cube plus b cube is a plus b whole cube. A plus, or let me do like this. Instead of keeping this alone, a cube plus b cube minus a plus b whole cube. I will shift this to the left hand side or right hand side. This to the left hand side. This will give me minus 3ab into a plus b. Both are same, sir. However, the way you want, you can do it. Right now, a cube is 55 cube plus b cube is 17 cube minus a is 55, b is 17. 55 plus 17 whole cube is nothing but 72 cube. This is nothing but my question, right? This is nothing but my question. If I simplify, minus 3 into a is 55, b is 17, a plus b is 55 plus 17, it is 72. Now, this is divisible by which of the following? It is divisible by, or it is a multiple of which of the following? Both are same. It is a multiple of both 3 and 17. Out of the given options, it is a multiple of 3, it is a multiple of 17. Answer should be both 3 and 17. Getting the idea? Very easy. You just need to know the a plus b whole cube formula, which is nothing but our 8th or 9th standard formula. It's not a difficult one also. Idea clear, sir? Please make use of this application. Now, next question is a very, very good question. Please listen to this question carefully, sir. It's a question on high level question which involves permutation, combinations, logic also. Now, please listen to this question. First, let us read the question, then we will solve this question. Now, please read this question. Sam has forgotten his friend's 7-digit telephone number. He remembers the following. The first 3 digits are either 635 or 674. That is the first thing that he remembers. Second thing is, the number is an odd number. Third thing is, and the number 9 appears only once, right? The number 9 appears only once. If Sam were to use a trial and error process to reach his friend, what is the minimum number of trials he has to make before he can be certain to succeed, right? Now, what they are telling, let us read statement by statement. Now, see here, they are telling that Sam has forgotten his friend's 7-digit telephone number. First thing is, we understood that it is a 7-digit number, right? It's a 7-digit number. Second point, he remembers the following. The first 3 digits are either 635 or 674. That means the first 3 digits, out of these 7 digits, first 3 digits are either 635 or it is 674. This is what is given in the next statement. The number is an odd number. Odd number means it should always end with 1, 3, 5, 7 or 9. Right? The number should end with 1, 3, 5, 7 or 9. And the number 9 appears only once. The number 9 will appear only once. If Sam were to use a trial and error process to reach his friend, what is the minimum number of trials he has to make before he can be certain to succeed? Now listen to this carefully. Now they are telling that the number 9 appears only once. Right? The number 9 appears only once. There can be 2 scenarios. First of all, first 3 digits can be 635 or it can be 674, right? Or it can be 674. Now, number 9 appears only once. There are 2 scenarios. First scenario is number 9 will come at the last digit, right? The number 9 can come at the last digit. That is the first scenario. Or the second case is the first 3 digits are 675 or the first 3 digits are 635 or 674. This can be the first 3 digits. First case is where the number 9 is the last digit. Second case is the number 9 is not a last digit, but it can be any of these 4th, 5th or 6th positions, right? That is what the second case is. Now let us solve both the cases. Now Suppose as per the first condition, if the number 9 is the last digit, this position can only be occupied by 9. That means there is only one way of filling that position, right? There is only one way of filling the position. Next, the other numbers can be repeated. There is no rule that they should not be repeated. Only number 9 should come once. That means this position can take any digit from 0 to 8. There are 9 ways of filling this position, right? There are 9 ways of filling this position. This position also can take any digit from 0 to 8, 9 ways. This position also can take any digit from 0 to 9, 0 to 8, 9 ways. That means 9 into 9 into 9 into 1. So it is, here it is 9 cube ways. Similarly, OR is nothing but addition. Here also this position can take any digit from 0 to 9, 0 to 8. Here also 0 to 8, here also 0 to 8. Again 9 into 9 into 9 into 1. It is again 9 cube cases. That means when the number is ending with 9, totally you have 2 into 9 cube possible cases, right? Totally you have 2 into 9 cube possible cases. This is a case where the number is ending with 9, right? Now, second case, the number may not be end with 9, right? It may not end with 9. It can be any of these positions. Now suppose if number is not ending with 9, question also says that it should be an odd number. Odd number means this position can be any number from 1, 3, 5 or 7. I can also put 9 because 9 case is already discussed here. So there are only 4 ways of filling this position. Similarly, here also there are only 4 ways of filling this position. Now, number 9, it can come here. Suppose if number 9 comes here, right? This is the only one way of filling. This can take any digit from 0 to 8, 9 ways. This can also take any digit from 0 to 8, 9 ways. So your answer for this should be 9 into 9 into 1 into 4. So it is 9 square into 4, right? It is 9 square into 4. But think logically, 9 square into 4 is the answer only if 9 is coming in this position. But 9 can also be present here, right? That means if 9 is not here, 9 can be present here. That means that is another 9 square into 4. Or 9 can be present here also. That is one more 9 square into 4. That means if 9 is present here, 1 9 square into 4. 9 is present here, 2 into 9 square into 4. If 9 is present here, again the same term, 3 into 9 square into 4. That means it is 3 into 9 square into 4. Or in other words, 9 square into 4 plus 9 square into 4 plus 9 square into 4. And the same thing happens in the below condition also when the 3 digits are 6, 7 and 4. And it is an OR condition. OR condition means same thing will be added once again, right? That means for the second case, your answer should be 2 into 3 into 9 square into 4, right? 2 into 3 into 9 square into 4. But the case can be a case where the unit digit is 9 or the unit digit is not 9. It is again an OR condition. So I should add these two to get the final answer. If I add these two boxes to get the final answer, so my final answer will be 2 into 9 cube plus 2 into 3 into 9 square into 4. If I simplify this, I'll just erase this so that I will have some space. If I simplify 2 into 9 square, if I take common factor, it is 9 plus 3 into 4, 12. So it is 2 into 9 square into 21. That means your answer should be 2 into 9 square into 21. Some people will solve this 2 into 9 square into 21 to get the answer. Let us not solve it, sir. Now please see the answer options. Using the answer options, we will try to eliminate some options. 10,000, 2430, 3402, 3006. These are the 4 answer options. Now see here. Answer should be a multiple of 2. All of them are multiples of 2. I cannot eliminate anything. Answer should be that 21 can be written as 3 into 7, right? It is 3 into 7. That means answer should be a multiple of 3 and 7. This is not a multiple of 3. This is ruled out. This is a multiple of 3. This is a multiple of 3. This is also a multiple of 3. But answer should also be a multiple of 7. Because 21 is 3 into 7. That means this is not a multiple of 7. This is also not a multiple of 7. Therefore, this should be the correct answer. You need not multiply and get the answer. Think little bit smart so that you will eliminate all the other options and you will end up with the correct answer. Answer is 3402. I think you are very clear. First case is when the unit digit is 9. The next case is unit digit can be here or here or here. If it is here, it is 9 square into 4. Again here, another 9 square into 4 added. Again here, another 9 square into 4 added. 3 times if I add 9 square into 4, it is 3 into 9 square into 4. Same scenario applies when the 3 digits in the starting are 6, 4, 6, 7, 4. Again same thing will add. That means adding 2 terms same time is nothing but multiplying by 2. This plus this will give you the final answer. Instead of multiplying and getting, use this elimination process. Clear with these two, right? That's very easy questions. Now please see the next question. Now, this is again based on reminder. Fifth one. Now your question is the integers 34041 and 32506 when divided by a 3-digit integer n leaves the same remainder. They are telling that two numbers are divided by the same number and they will give the same remainder. What is that number? What is the value of n is the question. Now see here, they are telling that remainder when 34041 when divided by n and the remainder when 32506 when divided by n, they will give the same remainder. The reminders are same, right? The both reminders are same. What is the value of this n is the question. And the options given are 289, 367, 453, and the last option is 307. Right? These are the given options. Now see here. Suppose a small scenario. Suppose remainder when 7 when divided by 3. This remainder is 1, right? This remainder is 1. Can I write this 7 as 3 into some constant plus the remainder, right? In this question, in this example, the constant is 2. That means numerator can always be written as denominator into some constant plus the remainder, right? Numerator is nothing but denominator into some constant plus the remainder. I will use the same application here. Now see here. Now listen to this. Here, numerator is nothing but equal to denominator into some constant plus the remainder. I will call the remainder as r. Here, numerator is nothing but equal to denominator into some constant plus the remainder. Now if I simplify these two, if I subtract it, 34041 minus 32506, it is 1535. It is n into a minus b. Plus r and minus r will cancel, right? Plus r and minus r will cancel. Now they are asking that out of these 4 values, which is the value of n, right? Which is the value of n? Suppose if it is something like 6 is equal to 2 into 3, right? 6 is equal to 2 into 3. That means this 6 is nothing but a multiple of 2 and it is also a multiple of 3. That means 1535 should be a multiple of any of these 4 numbers. Which of these numbers is what they are asking. 1535 should be a multiple of any of these numbers. What is the answer they are asking? 1535 is nothing but a multiple of 307. That means the answer for this question is 307. Or the other way of thinking is 2 should be a factor of 6, 3 should be a factor of 6. That means the n value should be a factor of 1535. Out of the given options, the only number which is a factor of 1535 out of the given options is 307. Getting the idea? It's a very easy way of solving. That is what I was telling from the previous problems. You have bigger numbers, make it as smaller number. You have bigger numbers, make it as smaller numbers. Use the same application or use the same, cyclicity process. That means the corollary. Whatever you use it here, same thing should be applied here also. That means they both should match. Such kind of smaller example, take it, replicate for the bigger number. That's what I basically mean. Idea clear, sir? Please write down. I hope the previous question is clear, right, sir? Now see here, next question. Please read the question. Let S be the set of prime numbers greater than or equal to 2 and less than 100. Now, they are defining a set called as S. They are telling that it is a prime number greater than or equal to 2 and it should be less than 100. So, the set is nothing but 2, 3, 5, 7, 11, etc. till 97. Right? Now, 97 is the last 2-digit prime number. Next, less than 100 is what I am talking about, sir. Next. Multiply all the elements of set S. You need to multiply all these elements of set S. Your question is, with how many consecutive zeros will the product end, right? How many consecutive zeros will the product end? That means they are asking the zeros at the end, that is nothing but the trailing zeros, right? That's the trailing zeros. Now first of all, when will a number end with 0? A number will end with 0 only when you multiply 2 and 5. 2 into 5 is 10, it is ending with 1 0. That means if I take 1 2 and if I take 1 5, that will end with 1 0. If I take one more 2, it becomes 2 square. If I take one more 5, it becomes 5 square. 4 into 25 will be 100. It will end with 2 zeros. That means if I take 1 2 and 1 5, 1 0. If I take 2 2s and 2 5s, it will be ending with 2 zeros. Like this it continues. In the same way it continues. Now they are telling that you need to multiply all these numbers. But if you observe carefully, in this set, these are all prime number set. In a prime number, the only prime number which is an even number is nothing but 2. Rest all numbers which, if it is ending with 2, it will not be a prime number. That means there is only 1 2 in the given set. Similarly, any number you take which is ending with 5, it is not a prime number, because all the numbers ending with 5 other than 5, all are composite numbers, because all those numbers are divisible by 5. That means you have only 1 5, you have only 1 2, and you have only 1 5 in the given set. If I multiply, you will get only 1 0. How many zeros will the product will end is the question. Answer will be how much? It will be only 1 0. Answer is idea clear? It's a very easy question which consists or which talks about the number of trailing zeros. Trailing zeros is nothing but the number of zeros at the end, right? The number of zeros at the end. Now, before you write it, first listen to the next question. I hope this problem is clear, right? Next question. Now, question says, let n is equal to 1421 into 1423 into 1425, right? 1421 into 1423 into 1425. What is the remainder when n is divided by 12, right? What is the remainder when n is divided by 12? Remainder when n is divided by 12 is how much? Now, they are asking remainder when 1421 into 1423 into 1425, this is divided by 12. Now we already discussed in remainder topic, instead of multiplying these three bigger numbers, finding the product and then dividing it by 12, which will take a lot of time to compute, you can actually divide it individually. That means remainder when 1421 is divided by 12, just divide for one number, because if I divide 1421 by 12, what is the remainder? 12 into 1 is 12, it is 2, 22, again one time it will go 10, it is 101, 101 is 5, remainder is 5, 101 when divided by 12 is 5. That means 1421 by 12 is 5, 1423, which is 2 units more than 1421, it should give you 7, 1425, which is 2 units more than 1423, it should be 2 units more than 7, 9, divided by 12. Again simplify it. Again, instead of multiplying these three numbers, multiply 2 at a time. 7 into 5 is 35. 35 and divided by 12. What is the remainder? 11. Or negative remainder is minus 1, because 35 divided by 12. 12 into 3 is 36. It is exceeding by 1 unit. Put a negative sign. So negative remainder is minus 1 into 9 divided by 12. So it is minus 1 into 9 is minus 9. Whenever you get a negative remainder, add 12 or add with the denominator. Denominator in this problem is 12. What is 12 minus 9? 3. The remainder for this question is 3. Right? Please do not multiply these 3 and then find the value and then divide by 12. It's a very lengthy process. Similar way of questions is already solved in our regular classes also. Idea clear, sir? Please write on this. Now listen to the second question, sir. Your second question says BE whole square. BE whole square is given as MPB, right? BE whole square is given as MPB, and they are also telling that BE, M and P, these are distinct integers, right? They are giving that these are distinct integers. That means no two integers are same. They are asking you what is the value of M, right? They are asking you what is the value of M. Now see here, it's a very good question where you need to think a little bit. Now think logically. BE is nothing but a 2-digit number, right? It's a 2-digit number. When I square a 2-digit number, I should get a 3-digit number. That means the minimum number BE can take is 10, because 10 square is nothing but a 3-digit number 100. That's the first 3-digit number which will start. Similarly, the maximum number BE can take is 31 because 31 square is 961. That is the maximum 3-digit number. When you square a 2-digit number, you will get the maximum 3-digit number as 961. That means, can I say that MPB it lies from, it can vary from any number from 100 to 961, right? It can vary any number from 100 to 961. This means that B can vary from any number from 10 to 31, right? B lies from any number from 10 to 31. Now, think logically. If B lies from 10 to 31, this letter B can take any digit from 1 to 3. It can be 1, 2 or 3 because the maximum digit B can take is 3 itself and the minimum digit is 1. So other digit is 2, right? B can be any digit from 1 to 3. Now, but B cannot be equal to 2 and 3 because if B becomes equal to 2, then here also B will become equal to 2. B square is nothing but a perfect square, right? B square is nothing but a perfect square. Perfect square, it cannot end with 2, it cannot end with 3 because the perfect square cannot end with 2 and 3. Perfect square never ends with 2 and 3, right? It will never end with 2 and 3. If I substitute B value 2 here, this also becomes 2 and this is a perfect square because left hand side is a perfect square, so it cannot take 2. Similarly, for the same reason, B cannot take 3. That means the only possibility for B is nothing but equal to 1, right? The only possibility for B is nothing but equal to 1. That means BE can vary from 10 to 19. Now we have condensed our domain from 10 to 31 to 10 to 19, right? Now continue it further, sir. If B varies from 10 to 19, when I square this BE, 10 square should give me 100. It is giving you 100, but B value is 1. Here 100 B value is 0. It cannot be a possible case. 12 square, if I take B as 12 square is, B value here is 1 if I substitute B as 12. B value is 1. Here B value becomes 12 square, 144, 4. 1 and 4 they are not same, right? But B and B they are same in both the places. So it cannot be a possibility. That means the only possibility BE can take is either it is 11 or 19 because B square, if it is 11 square is 121. Here also B value is 1, here also B value 1. Similarly, B square, if I take it as 19 square is 361. Here also B value is 1, here also B value is 1. These are the only two values which are satisfying. But out of this value will not satisfy because question says B and E are distinct integers, but here you are putting B and E as the same integer 1 and 1. This case is ruled out. The only case which can be possible is B square is 19 square. 19 square is 361. That is MPB. In place of M, what value you have? 3. That is what is asked in the question. Answer is M value equal to 3. Getting the idea? Because they are telling that B are distinct integer. These two cannot be the same values. Idea clear? You need to think little bit to solve this question, sir. I hope the approach is clear, right? Please write down this question. Hi all. In this session, we will be discussing some of the very interesting questions and some of the very interesting topics on number system previous year CAT questions. Perhaps number system is one of the very easiest and the interesting topic, but still there are some set of students who find number system as a difficult topic. Let us solve in today's session the number system previous year CAT questions from the year 1998 to 2008, and let us erase that fear in students saying as number system is not a difficult topic, but perhaps it's a very easiest topic if you are solving by the way of ANIL NAIR classes. Let us not waste much of our time. Let us solve number system problems on previous year CAT questions. Please write down the heading, sir. Number system previous year CAT questions. Number system previous year CAT questions. It's a very interesting topic. Now listen to this carefully. Let us solve with or start with the CAT 1998 paper. We will slowly move on to the next level papers or the next year papers. Let us first start with CAT 1998 paper. Now please see the sheet, sir. If you see the sheet, there are close to some good number of questions which has come in CAT 1998. Let us solve one by one to understand how beautifully or easily we can solve CAT questions without using pen also in some of the questions, right? Now please read the first question. Your first question says, n cube is odd which of the following statements are true? They are telling n cube is given as odd number. Now see here, they are telling that n cube is odd, right? N cube is odd. They are telling which of the following statements are true. The first statement is n is odd, right? The first statement is n is odd. The second statement is n square is odd. And the third statement is n square is even, right? N square is even. Now, out of these three statements, which of the statements is true is what they are asking, given that n cube is odd. Now, the best way to solve questions on number system is take any numbers of your choice which satisfy the given condition. For example, n cube is odd means, can I say that 3 cube is odd? I am taking some number, whatever number you want to take it. But make sure that this should satisfy the condition as odd number, right? 3 cube anyway is 27, which is an odd number, right? Now, if 3 cube is odd, I have put n value as 3 here. Substitute in all these cases. 3 is odd, yes, 3 is an odd number. 3 square is odd, yes, 3 square is nothing but 9. 9 is also an odd number, right? But this is also true statement. But if I take the last condition, n square is even, that means 3 square is even. 3 square is not an even number. So last statement is not the correct statement. That means which among these three statements is the correct statement is what they are asking. So the answer for this question is 1 and 2. First and second statements are true. That is nothing but your option C. In the given options, it is option C. Getting the idea? You take any number of your choice, but the only thing that you need to satisfy is you need to make sure that whatever the number which you are taking should be an odd number according to the given question, right? According to the given question. For example, 5 cube. 5 cube is 125. It is an odd number. But I cannot take 4 cube because 4 cube is nothing but 64. It is not an odd number. Take some numbers of your choice which will satisfy the given question. There are so many questions in number system where we will solve so beautifully only by taking numbers. Idea clear, sir? First write on the first question.
You can learn any subject, anywhere, any place and on the go. Come, let us go the other way in learning. Download our revolutionary app for free.